Good. Okay, how are you? And then I'm going to talk to you about solving the two problems on nuclear chemistry on chemistry 2. The first problem is balancing nuclear equations. And the problem looks like this. This is either emission of alpha or beta rays or even something positron emission and the electron captures. Here I want to give you a little warm-up. So this is a slide that you might have seen from the lectures. I just make a little modification. This is one of the experiment run by the Rutherford, and he made this test, the vacuum tube, and then he essentially generate this kind of the emitted particles or emitted rays, and he defined the first one that he saw is an alpha, the second one is beta, and then the third one is a gamma. And the alpha ray is the first one that he find out it is being attracted to negative terminal here, and that is happen to be that the alpha ray is something with essentially helium with helium nuclei. So helium has atomic number 2, and the mass, atomic mass is essentially the 4, so that's an alpha ray. And there are also something that is attracted to the negative one. At that time, there was the concept of an electron was not so popular, so he called it as a beta ray, and the beta ray later is called as a electron. So electron has something like a charges of -1. So instead of using the number of protons, so this is almost like an imaginary number. So it's the -1. It's sort of you can think it as a charge, okay? And then the mass is, although electron has a mass, is compared to the nuclei mass, sometimes the neutrons and proton, it weighs nothing, so we just put it as a 0. Okay, and then there is something that doesn't do anything. The electric field going pass through it, they just pass through it right away, and this is something we call gamma ray. And gamma ray is just an electromagnetic radiation. You remember the h nu that we talked about? The energy is an h nu. Just an electromagnetic radiation. In the notation of nuclear chemistry, say, okay, this one do not have charges, and this one do not have a mass. So sometimes they use these notation as well. And then there is something called positron. This positron is something, so you call it beta. Beta is an electron, right? So beta is an electron. Positron is, they call it plus. Okay, so that's a positron, and this is sometimes they call it a beta minus as an electron emission. So just make sure the charge is different in the opposite side. And this is the table that I hope you guys are being familiar, right? There we talked about proton, neutron, electron, alpha ray, beta ray, but beta can be positron or an electron, right? So this is an electron, which is a beta ray, and then a positron, which is a beta plus. And then, so that's the number. Okay, so I don't know why this one is showing this, but beta positron means beta plus. Okay, and then this table, the periodic table, we're going to use quite a lot. So let's get on to the problem and solve this problem one by one. Okay, so let's do the first one. So we just keep tracking of number of protons and charges and something like neutrons, and you understand this. What matters here is atomic number is defined by number of protons. That's the most critical information. Okay, so alpha emission. So what did I say about an alpha? Alpha was helium with 2 protons, and the atomic mass is 4, and alpha is strictly, actually speaking, is 2 plus charges, the particles. And the plutonium, and then I have to look at where the plutoniums are, and if you look at that, plutonium's right here. So what number do you see, right? 94, right? So plutonium has a 94, so I will put a atomic number, as a 94. I will also use a notation P here. P is a number of protons that I would like to keep track of. And it says a 245 means a number of protons and number of neutrons is essentially 242. So those are the numbers. So from this equation, you can easily calculate number of neutrons if needed. But let's just write the answers. So alpha emission from the plutonium. So I'm going to write plutonium, which is shown up here, symbol Pu, plutonium. Plutonium atomic number is 94, and the total mass is 242. Okay, so this is one of the isotopes in the plutonium. And then they essentially emit alpha ray, and then they ended up having what? So if you look at that, your G number 94 should be subtracted by 2 because you lose 2 protons, and that's a 92. So that is a challenge here. So 92 means what? You becomes uranium. Okay, so you put U and 92. And then what about the mass? Mass is essentially 292 minus 4, 238. 238. And then if you look at the charges, this one, you should have 2 minuses. And people actually also write this one, although alpha particle is positively charged particle, just the charges, they will take the electron from anywhere to be a stable helium. So sometimes they write it this way, and actually it's much more common to write the balanced equation, 92 uranium with a mass of 238, without showing the charges. And that's probably the answer that people will use. Okay, so let's go to the second one, is a beta emission. So beta is, what was it? It was the electron. Okay, so that was just the name. The beta was electron, so -1 and 0. Okay, no mass, sort of the -1 charges, or -1 proton, quote unquote, if you want to think about it. And the magnesium 28. So 28 means proton numbers and neutron numbers are 28, but it didn't say anything about their Z numbers, right? So Z number, you should go up. And where's the magnesium? So do you guys see the magnesium here? Magnesium. Oh, okay. I completely missed that one. Yes, here we go. The number 12. Yes. So that's an alkaline earth metal. Yeah. Yeah. Mg is usually Mg2+. So right. So that's a 12. So Z is 12. Okay. So that, having said that, I can start to writing this equation now. Mg, magnesium, which is atomic number 12, and 28 protons plus neutrons. They are decayed to emit beta ray. And then what will be atomic number? Okay, 12. Now the -1, that will be a 13, right? So if you think about it, 12 minus -1 will be 13. So 13 is, I guess, the one higher up in the atomic number. That's aluminum. Okay, so we got the aluminum here. And then what else? 28. So I think that this is the answer. So for the second problem, just a matter for you to keep track of number of positron, number of protons and number of neutrons, and the atomic number, as we say here. Okay, the third one is a positron emission. positron, and positron is, we are using symbol E, and no mass, and the charge is +1. Okay, so this is how it looks like. And the silicon, so silicon, where are you here? Do you guys see the silicon here? Right, silicon, I know it. Yeah, this right here, that's a number 4. Silicon is underneath the carbon, okay? The silicon. So silicon is a number 14, so Z is 14 here, and then N plus P is 26. Okay, so then how can you write this number is okay, then I can do okay, starting from silicon, so silicon Si and Z number 14 and 26, and then they are emitting positron, and then what that means is you will have a 13, your atomic number. So atomic number 13 is, I guess once again, is an aluminum. Okay, so aluminum. So by losing 1 proton, you're making this one into the aluminum. So aluminum. And what about the mass? Mass doesn't change, so you ended up having this. The last one, this one is a typo. This is a 37, and I corrected for the LMS posting, so you have the same one. So the last one is what is called the electron capture. So this says electron, so okay, electron, no mass, -1. But its capture means when you put the argon is AR. AR is a Z. What is my Z number in argon? I know argon is a noble gas. That's right. Here is an argon, which is 18. So therefore, argon 18. So an 18. Okay. Just for you, once more, and plus P is 37. That's what it is. But anyway, electron capture means argon, which is atomic number 18, and total mass is 37, is going to react and capture, so the -1 and 0. Okay, electron will react, and then you will see that 18 minus 1, that will be 17, and 37 plus 0 is 37. And what's the atomic symbol for 17? Which is this one, right? It's a chlorine atom. So that's the answer. Okay. So this is our answer for all the 4 problems. You can also find the answers right here. That is in the written form. Then you can just come from it, and I can put all the answers in a written form on the LMS as well as this YouTube video. Thank you for your attention.